variables that are correlated show some kind of relationship. For example, in an earlier example, we studied how the temperature outside and the number of customers at a froyo shop were related. And we saw that as the temperature increased, the number of customers tended to increase too. Some relationships between variables show a negative slope or a negative relationship. As an example, consider the relationship between earning F's in classes and high school graduation. So you might be able to imagine that as the number of F's increases, so as the number of F's people earn increases, the graduation or on-time graduation rate decreases. So you see a negative association. So think about linear relationships. When the relationship between variables show a line when graphed, there's either a positive slope, a negative slope, a zero slope, or undefined slope. In this section, we'll be rating those relationships on a scale from -1 to 1. And this rating scale is going to be called our R values, or our correlation coefficient. In this unit, correlation is a measurement of strength, how powerful the relationship between the two variables is. We measure the correlation strength using a rating called the correlation coefficient, or R. So if the R's value is close to either -1 or 1 over here on the edges of the rating system, the relationship between the variables is very strong. Either a very strong negative relationship or downhill slope, or a very strong positive relationship or uphill slope. If the value is in here closer to 0, that means that there's a weak association between the variables. So if it's on this side of 0, it's very weak in the negative direction. If it's on this side of 0, it's very weak in the positive direction. But if it's at 0, there's no association between the variables. Now, look at graph A. First, decide if the data shows a negative trend, a downhill trend, or a positive trend, or an uphill trend. So in this case, I bet you're seeing that it has a downhill trend. That decision, uphill or downhill, will narrow down the answers to 2 choices. So here are our choices. We know that there's a downhill or a negative trend, so we can already eliminate the positive answers. We can eliminate this answer, we can eliminate this answer. Next, decide if the slope of the line is fairly steep or if it's fairly flat. So in this case, it's pretty steep, right? It's closer to this, a steep slope, than it is to this, a very gentle slope, or this, a very gentle slope. So this is pretty steep. So it's going to have, remember our rating system, if it's pretty steep, then it's going to be close to either -1 or close to 1. So in this case, since we're talking about a downhill slope, we know it's going to be a number that's very close to -1. So between this option and this option, negative 9/10 is a lot closer to -1 than negative 9/100 or negative 900. So in this case, this is the option that's closest to the correlation coefficient for this line. Go through that same thought process for graphs B and C. Decide if the trend is strong or weak. If it's strong, it has a steeper slope. If it's weak, it has a gentler or flatter slope. And then if the points of the scatter plot don't resemble a line, the R value will be very, very, very close to 0. So one of these looks like a line, right? And the other one is a little bit harder to see a line. The one where it's harder to see a line will have a number that's very close to 0.